Okay, course 3, lesson 101 deals with probability. Probability with areas of geometric figures like circles, and later we'll get into squares too. Two things to review to make sure you're feeling good about some concepts. Two things you already know about. Area of a circle, all right? We're going to be dealing with that today. Is found, we need to know diameter or radius, because diameter gives you radius. You take that half a diameter and you square it, multiply it by pi. Okay, don't forget that. Then probability is found with more or less the same ratio no matter what. What's always on top? It's what we're looking for. For example, what's the probability of drawing a blue marble? Well, we'd put how many blue marbles are on top. How about the bottom? I guess I'll just summarize it with the word total. We'd put every color included there, the count of all the marbles no matter what color. Now, we're going to use areas in this ratio to tell things like the probability of hitting the bullseye on a target. And probability, remember, is something measured between 0 and 1, right? Or if shown by percentages, that'd be 0% to good old 100%. But 1 in percent is 100%. 1 means you can only get that option. So, and we're not counting, completely misfiring and hitting over here. Some wise guys want to say, what about that area? We're not counting that right now. If you were to blow up, it looks comical. The blue is the bullseye. If you blew that up to be the size of the entire target, what's your probability? It's roughly, you can't hit anything else. It's 100%. Between 0 and 1, you're 1. The bigger you make your target, the higher the probability. Smaller it gets, at this point, they tell us it's a 1/10 probability. The area of this bullseye compared to the area all around it is 1/10. Now we're including all of this as the other group, as the complement. So that's 90. That's 0.9. And this is 0.1. So if the bullseye basically effectively disappeared, the probability of hitting it would then become 0. The bigger it is, the higher the probability. So if they ask you about a target that has a 12-inch diameter, I'll try my best to draw this. It's not a very good circle, but at least it accomplishes the task. And the bullseye is 4 inches in there. Okay, I'm not going to draw the 4, it's going to get confusing. What's the probability you hit it if we're not counting the outside? To find geometric probability, we're looking for area of what we're looking for, right? So bullseye over total. Area, I should maybe put a big A and a big A. We're finding areas compared. So what's the area of a bullseye with a 4-inch diameter if it's a perfect circle? 2 squared is 4 times pi. I'm going to leave it because in a ratio, a lot of times you want to leave the pi on there in case it will cancel. Area of the total, the radius is 6. 6 squared is 36 times pi. That's the target. And we have a nice reducing situation here. Cancel out your pi's. Divide top and bottom by 4. 1/9, or shown in decimal form. So you'd have to go like this. $11/100ths-ish, right? They just went to hundredths. They probably had to round and stop there. This is again called geometric probability. Assuming an object lands with equal probability at any point in a known region. With that said, the probability is the area of the specified or the region we're looking for over the area of the total or known region. Just like when we found probability of drawing a marble. Now this works also for these odd, I don't know what this situation is, but what's the probability that if you dropped an object, it's going to land in the circle outer region? What is the probability that an object that lands in the circle also lands in the square? Okay, so they're saying in the circle so that you don't argue, well, it is in the circle. Yes, but we're specifically talking this square region, 10 by 10 square. So basically, we want to know this compared to everything, which includes the square, but also includes the circle. So we want area of square compared to area of whole circle. That gives us our geometric probability, okay? Notice they gave us the diameter of the circle on the outside so that it wouldn't get crowded on the inside there. That's 20. How do we find area of the square? 10 squared. Area of the circle? Radius is 10. Ooh, 10 squared looks the same. Times pi. These effectively will cancel. Otherwise, you can still show it like this. But really what we end up with is 1 over pi, right? That's the way I did it. Like they did it on the right side here, leaving pi as pi or solving in terms of pi. You end up with 1 over pi. And they don't even divide that out. So your answer is 1 over pi. Notice how leaving pi in there makes it real nice when you're using things like ratios because of that reducing top and bottom. Why don't you pick 2 of these? Finding the probability that an object lands in that inner region, a lot like what I just did with example 2. And then look for the 2 answers you chose in the lesson practice answers posted tomorrow. Please note what assignment is due for next math.